Lesson Overview 1.03 Triangle Similarity Part 2. In this lesson, we will solve mathematical problems and real-world problems using similar triangle theorem. We are going to use the angle-angle similarity postulate, which says if two angles of a triangle are congruent to two angles of another triangle, then the triangles are similar. Notice all we need to know is are they or are they not? Postulates are because I said so. It's true, does not need to be proven. We're also going to use the side-side similarity theorem. That says if three sides of a triangle are proportional to three sides of another triangle, then the triangles are similar. Notice that this is a theorem or a theory or a thought. I think if these are proportional, then they will be similar. Let's see if they're proportional. Means that we need to find out if they're proportional. So what you'll do is you'll take the consecutive sides. So that means purple to purple, right? If I were to slap these on top of each other right here, we see that AB goes along with DE if I were to make it smaller, right? Or make it larger. That's their similar side there. So I'm going to put AB with DE, and then I'm going to find one of the other sides. Now, if I'm using side, 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 I must prove that all three of these sides are equal, just like we learned in our last lesson. We also have the side angle side theorem, which has to be proven. This says that if two sides of a triangle are proportional, which is where we have to prove it, then the two sides of another triangle, and if their included angle is congruent, then the triangle's similar. So in other words, we're going to take our consecutive sides here, which would be A and C in this image's case, and D and F, and we're going to say that these two proportions would equal each other. That would mean that if I divided AC by DF and I divided BC by EF, they both have to equal the same. In addition, because the orange line is connected with this angle right here to the blue line, this angle has to be the same measure as this angle. So it has to be the same number of degrees as this angle in order to use this side angle side theorem. So let's go ahead and get started. First problem, we're going to determine the value of x given that triangle ABC is similar to triangle DEF. Now, we notice that BC measures 22. That's been given to us. And we also notice that CA measures X. We can see that BC corresponds with EF and that CA corresponds with FD. Therefore, we're able to set up a proportion. Now, one more thing. This is going to be side angle side. Not that you need to know that because it didn't ask that. But if we were trying to prove this, we can see that C has just one arc mark and F has just one arc mark, which tells us that these two angles are congruent. That's just a little side note. Okay, so let's go ahead and get started. We're going to set up the proportion to solve for x. When we solve for x, we have to cross multiply. So we're going to say that CA corresponds with FD, which is equal to BC, which corresponds to EF. And then we're going to substitute CA with X and FD with 22. substitute BC with, with 72, FD. FD is 72. And BC with 22. And then EF with 30. Now we're going to cross multiply, and that's going to give us 30x is equal to 72 times 22. Now all we have to do is plug this into our calculator. 72 times 22 is 1,584. Go ahead and divide that by 30, and you get that x is equal to 52.8. So we can say that the value of x for a triangle ABC is equal to 52.8. Now let's show that triangle MNO is similar to triangle PQR, and then determine the value of x. So the first thing that we notice here is that NO is parallel to RQ. Or as our note down here says, NO is parallel to QR. And we would want to say that because remember, we want to put them in order. And we see here that angle N is 90 degrees and angle Q is 90 degrees. Therefore, when we're using corresponding sides, we would say NO corresponds with QR. That means that they line up together, right? And also we see that RO is the transversal. So this gives us all kinds of rules because we have a parallel line with a transversal. The figure shows that QR is parallel to NO, which we just determined, using RO as the transversal. We see that angle QRP and angle NOP are alternate interior angles. Therefore, angle QRP, so we find QRP by connecting the dots, QRP, and we focus in on that middle letter right here. So we're looking at this letter right here, R. And so this angle R and this angle O are alternate interior angles. That means that they're congruent. So now you have two angles in our similar triangle that are congruent. And we also see, well, you have one angle in two triangles. But you also see that these two angles are congruent because they're both 90 degrees. So using the angle-angle similarity postulate, we know without a shadow of a doubt, because we said so, that triangle MNO is similar to triangle PQR. Now let's determine the value of x. We're going to set up our proportions so that PQ is divided by MN, which is equal to QR divided by NO. We're going to go ahead and substitute our values so that we say x, which is PQ, and MN, which is 36. Plug those in. And now let's cross multiply. To cross multiply, that just means that I multiply the top by the bottom and the bottom by the top. So when I cross multiply, I get 50x is equal to 36 times 40. Plug it into your calculator. Please use your calculator. 50x is equal to 1,440. Divide by 50, and we find by isolating the x and dividing both sides by 50 that x is equal to 28.8. Now we have one more here. Let's determine the perimeter, and this one's a little bit more detailed because we need to know every side, and we also notice that we have a y and we have an x that we have to solve for. So let's go ahead and look at how we're going to do this. First we're going to determine the value of x. We see that we have two angles that are congruent. So we know that these triangles are similar. And that's also been given to us. So we can just set up our proportion right away. We see that GH divided by JK is equal to HI divided by KI. When we plug in the values, cross multiply, we find that X is equal to 60. Then we go ahead and do the exact same thing for Y. So we're going to set up our proportions so that IG is divided by IJ, which is equal to HI divided by KI. Cross multiply, we find that the value of Y is equal to 80. Now we need to determine the perimeter P of triangle GHI. So this one right here is triangle GHI. In order to determine the perimeter, we're going to go ahead and add up all the sides. So P is equal to GH plus HI plus IG. 60 plus 100 plus 80 equals 240. And to write this in a sentence or a statement, we would say the perimeter P of triangle GHI is 240. If you have any questions about this lesson, please reach out via text or email.